Hi guys, we have discussed about the production function in earlier video, wherein we have talked that the functional relationship between the inputs and outputs I have explained, and this table also I have explained you, wherein we have talked about the A100 is the constant value A, that is intercept of Q, and then we have seen that the K and L are the two inputs, and these inputs are having a rate. For example, capital moves at the rate of 0.5 and L labor moves at the rate of 0.5. That 0.5 is the rate alpha and beta values, and they move at a given rate. That means wage rate and capital rate, we take them as a given constant, and for a given rate of capital and a given rate of wages, how many units we must undergo a change, which gives you the quantity, and that is how these values are calculated. I have already explained this. Now let us see the change that is normally takes place, like what are the inferences from this table. Let us understand the inferences from the table. Let us say, number one, the table indicates that there are a variety of ways to produce a particular rate of output. For example, you can take example, 245 units of output is there. It can be produced in any of the following input combinations. I will show you in the table because that you will understand better. I have taken the 245 245 units as the figure, and you have a 245 here also, and 245 here also, and a 245 here also. Now you see, what does it mean? It means this 245 cube, that is quantity of output, can be produced with a variety of combinations. The combination could be 6 units of capital and 1 unit of labor. Similarly, you can use 1 unit of capital and 6 units of labor also. Let me explain these two first. Suppose you are an example, you are after completing engineering, you start a startup company. Startup company, you do it at your house without paying any rent or whatsoever. You just take your smartphone and then develop an app. So you have developed an app, and that app you sell it and make it marketing. So what is that you are doing? You have 1 unit of capital, that means only yourself is the labor, L value. And there are 6 units of capital, because to buy a smartphone or to buy a computer, it will be around 30,000, 40,000 rupees you are investing. So you are investing about 6 units of capital, for example. Whereas you are the only worker, there is no other worker. This is called highly capital intensive industry. Similarly, if you go to Karimnagar district or Silsila in Telangana, you have a place where BDs are made. So BDs are made by ladies by making, tendu leaves they select. The tendu leaves which they pick up say tendu leaves because that will not absorb the tobacco, and the tendu leaves will not percolate into the tobacco. So tobacco is not polluted with the tendu leaves content in it. Hence, that is used as for the BD leaves. So when you insert the tobacco inside, and then they said just put it on the top and they will throw it. So each BD is made by the lady like that. There will be 100 ladies who will be making BDs in a hall. So what is the capital you are investing? To pay rent for the hall, that's all. And then you have all ladies working. So 6 units of labor and 1 unit of capital is an example you can take. You are producing same 245 units. So this is called labor intensive industry. Highly labor intensive industry is the 6:1. Highly capital intensive industry is 1:6. In between is these two. You have 2 units of labor and 3 units of capital, or 3 units of labor and 2 units of capital is the in between. That is the choice is yours. See, this is very, very significant for all of us to understand, because this microeconomics is the basis for macroeconomic politics, even politics. A simple example I'll give you. Because the labor is cheaper, the rate of labor is cheaper in India, Bangladesh, Pakistan and other areas, most of the American firms prefer to have a outsourcing by our countries. So outsourcing will make more laborer at a cheaper rate and investment will come down. So obviously entrepreneur prefers to outsource the firms. So when they outsource, whether Infosys or thanks to Narasimha Rao government in 1991, you have got all the most of the firms are able to have the collaborations with other countries, globalization, and that has provided large employment for the IT industry. So that is the best example we can quote for the labor intensive industry, the ratio, proportion, etc. Whereas if you take the Germany or New Zealand or Australia, they cannot afford to do that because the number is less with them. So they go for capital intensive industry. So this is the choice of going for a labor industry. Earlier they were doing purely capital intensive industry, they were not getting labor at all. Today you find every fifth person, every third person in the world is a Chinese person working anywhere in the world. Every fifth person in the world is working from India. That is how it's going on. So this internationalization of labor concept itself has come because of the terminology that you can have different input combinations to produce the output of 245 with different input combination. So this is the microeconomics basic economic theory which you are learning, which will help you in understanding the dynamics of political and economical things going on and how they change as such. So this is about the inferences when we talk about it. So what is needed for us is, you must understand that this is the combination. I have already explained this. This implies that there is a substitutability with the production. Substitutability between the factors of production. The firm can use capital intensive production process. I have already explained that. The concept of substitution is important because it means the managers can change the mix of capital and labor in response to the change in the relative prices of these inputs. So the relative prices of interest in capital, for example, interest on capital falls from the last 1 year of pandemic. The interest rates have fallen and the dividend rates are also in a question. Most of the firms were incurring losses. So if there is a change in the rate of interest or rate of capital that you get it, then if you are getting capital at a lesser rate, obviously we can think of having a more capital and less labor. Either way you can go for it. So as I said, macroeconomics also undergoes a change because of this. So this is one aspect. The second aspect in the same table, if we look into it, that in table, if inputs are doubled, the output also can be doubled. That means the maximum production with 1 unit of capital and 4 units of labor is 200. The input rates are K is equal to 2 and L is equal to 8. The results, the rate of doubling is Q is equal to 400. What does it mean? This 1 is doubled to 2, 4 is doubled to 8. So input are doubled. Then output also doubled from 200 to 400. Let me show you in the table. You will understand that. You can find this diagonal 100, 200, 300, 400, 500, 600 up to 800. You can find this entire diagonal is increasing like that. Why? Because this is the when you double this 1 to 2 and 1 to 2, this has gone to double. 2, when 2 is increased to 4 and 2 is increased to 4 here also, then you got 400. Like that this comes. This is this diagonal reflects the returns to scale. This is called returns to scale. You know why? Because returns to scale have implications with the size of Indian firms, size of the firm in industry. Example, producing a product, if output increases more than in proportion to increases in input, the industry is likely to have few large firms. What does it mean? As I have shown you in case of demand, elasticity of demand, I have shown you, wherein in production also, what happens is, suppose you take this as x-axis 0, y-axis, and here you show the quantity of output that you are producing. Here you are showing K and L figures. Suppose the curve of labor is like this. What does it mean? It means at a, let us say at a given L1, the output is Q1. And here if you L2 is increased up to here, your output is increasing here Q2. That means proportion of increase in the L1 to L2 is very small, but the proportion of increase from Q1 to Q2 is extraordinarily high. Then we say it is highly elastic. So the curve, if it is like this, then reverse will take place. The change in the input will be very high and the change in the output will be very less. So it is inelastic. So this is called the industry proportion. So when you take the example of US automobile industry, if it is highly elastic, then you will find that you will have a large number of firms because large inputs. Here you find that returns to scales have implications for the size of the firms and the number of firms in industry. For example, producing a product, if your output increases more than proportion to increases in inputs, the industry is likely to have few firms. Number of firms will be less because with a slight increase in L1 to L2, he is able to increase his output very high. So there is no need for large number of firms. Less number of firms will do. So US, Australia, New Zealand, they are having a large producing of cars because of this only. Unlike India, where you have large number of labor is there, so obviously when you go for a labor intensive industry, large number of labor will come forward to produce and the quantity will be different. So this is how you have to remember the impact of returns to the scale. Now further inferences of the same table if you take, in contrast, the concept to the returns to scale, there is also a returns to the factors of production. When output changes because one input changed while the other remained constant, the changes in the output rates are referred to as the returns to the factor. Returns to factor is also very important. Note that in the table, if the rate of one input is held constant while the other is increased, output increases but the successive increase becomes smaller. For example, in the table, if you keep the labor at 2 only constant and change the capital, capital you keep it as constant at 2 and labor you change from L1 to L6, your successive increases will be 59, 45, 38, 33. From 59 it has fallen to 33. I will show you on the table, you will understand better. Yeah, if you take this, he is saying that keep the capital constant, don't change this. Then go on changing the labor. So when you have 1 unit of labor, it is 141. When it is a 2 units of labor, it is 200. 200 minus 49 is 59. Then 45 minus 200 is 45. So from 59 it has fallen to 45. That means even though the total products increased, the increase or the additional increase will fall. That is called marginal. That is also called marginal. So marginal increase from 83 to 45 is 38. From 16 to this one is 17 plus 16, 33. Then here too is you find 30. Like that it falls. So additionally, always the additional increase in each unit as go on increasing, it will be falling. That is called decreasing. What decreasing? Diminishing. Diminishing marginal. Marginal means additional. Diminishing marginal returns. The returns on this is less. That's about the law of diminishing marginal returns, we say that theory. This is, you can expect in short notes, this question. Similarly, you find, when we put it in our mathematical terminology, you understand very easily. Total product is total two input production process. The total productivity LP, TP, total productivity TP is defined as maximum rate of output forthcoming from combining varying rates of labor input and with a fixed capital input. You are keeping capital fixed, denoting the fixed capital as K bar. The total product of labor, is function of K and L, where K is kept constant. That means if you take our AK, we wrote that AK to the power of alpha, L to the power of beta. This is what we have studied. So A is 500. You can take any figure, constant. As I have already explained you, it is the intercept of Y. So if it is quantity, this part is called A. It will be constant if you are taking quantity as x-axis and A value. So this is the A value 500, and K value is change in the K. Change in the K is on from y-axis. So you changed from K1 to K2. So change of K1 to K2. At what rate K is increasing is this 0.5, which we have taken, and L is another 0.5 we have taken. However, K must be kept constant, because if you keep one input as constant, the other one is changing, then you find L to the power of 0.5. So similarly, total product of capital function, reverse is the case. L is kept constant and then delta. When you talk about the marginal productivity, it is defined as change in the output for unit of change in the variable input. This is called, which what I have explained you earlier also in respect of demand. Here we say K1 is producing Q1, K2 is producing Q2. So this is Q2, minus Q1. This is called the change. This is, let us say, this is A and this is B. This distance is called Q2 minus Q1, and this distance, this is C, let us say. This distance we call it as K. It is a K2 minus K1. This difference. So BC divided by AB divided by BC is known as derivative. I think all of you know that. In derivatives you must have already studied that. Here I am also explaining, this is called as delta Q. Delta means difference between, you know very well, Q2 minus Q1. So Q2 minus Q1 is delta Q, divided by delta L is L2 minus L1. That is the defined as marginal product of labor. Similarly, marginal product of capital, delta Q by delta K. So that is how we calculate the marginal productivity of labor. I think being engineering students, you can understand easily. Production with one variable output input only we are continuing, wherein if it is the difference is infinitesimally small, if the difference is infinitesimally small, that means you are talking in terms of point elasticity. So instead of having 2 points, we take, let us say, one curve is like this. At a particular point, you want to measure the labor productivity, that you will use it instead of delta Q by delta L or delta K, we are using derivative of Q divided by derivative of K. Derivative is you know very well, I don't have to teach you. The basic concept is same. You assume at a particular point you have these changes, and that changes is, this is the one, A, B, C, and AB divided by BC is the derivative, but this is only imaginary because we are measuring at a particular point in this way. So this is how you use it, and same formula we calculate and do it. So this completes the marginal productivity part of it. Now the last part is average product. There is a difference between marginal product and average product. Marginal product is additional product. For every change, for a given change in the input, what is the additional quantity you have produced is called marginal product. Whereas average product is simple arithmetic mean what you study. Total number of products divided by number of units. So when you take the total number of inputs, number of units in inputs. So you take here that 500 TP, if you take total as 500, TPL divided by L to the power of 0.5, root of L, that's how you calculate. Same is the case with TPK, that is total productivity of K divided by K to the power of 0.5. So it is a number of inputs which divide the total value. So you get the value. Now if I take the table, I will show you with figures, examples. See, you have rate of labor 1, 2, 3, 4, 5, 6, 7, 8. Then let us say you take total product here for a given labor. Total products, if you are having 0 labor, your production is 0. If you have 1 labor, you are producing 20. If you have 2 labors, you are producing 50. If you have 3, 90, like that it goes. The MPL, I have explained you that the change in the quantity of output divided by change in the quantity of input. So 50 minus 20 is 30, divided by 2 minus 1 is 1. 30 divided by 1 is 30. And here 20 minus 0 is 20, divided by 1 minus 0 is 1. So 20 divided by 1 is 20. So this is how you calculate all marginal productivity. Whereas average productivity is total productivity minus number of units. 20 divided by 1 is 20. 50 divided by 2 is 25. 30 divided by 3 is 30. Like that we get the average value. This is average productivity value. So when you have these figures, what we can do now is we can see how the curve will appear. This is the last part of thing you must understand. Sorry, I have showing you a shabby picture because drawing becomes difficult on that. So if you take x-axis labor here, rate of labor input, and when you show y-axis as the quantity changes, etc., marginal productivity, I have drawn 3 curves. This is total productivity of the labor, and this is marginal productivity of labor, and this is average productivity of labor. Now let me explain the the relationship among these three, that is very important. That will take only 3 minutes. Number one, you find here that the total productivity curve is increasing at an increasing rate here, up to here. After this, you find that after this point, you find at this point, your marginal productivity is at the peak. And here it is, inflection of the total productivity curve is undergoing a change. Till now, the increase was an increasing rate. And here, no doubt total product is increasing, but increasing at a decreasing rate. And that is reflected in the marginal productivity, because additional product and this is a total product. Total product goes up continuously, which we have already seen in the table. And here this falls down. This falls down. And it intersects with the average product curve when average product is at the peak. And that point, from there if you draw a perpendicular, this is a point where your total productivity stops increasing. It will be stagnant. That is called stage 2 production. And here also your marginal productivity starts falling and your average productivity curve starts falling. Both will be falling, and the average marginal productivity reaches 0. Once 0 means there is no further increase at all. From here, exactly at 0 here, if you draw a perpendicular from there here, exactly at that particular place the total productivity curve starts falling. So total productivity also starts falling, average productivity also starts almost falling. So all curves will start falling here. This stage is called stage 3. So stage 1 is the introduction stage. Stage 2 has got 2 phases, where you reach the L2 is reaching peak and with the stagnation at this intersection point, that is L2, and from here to here is L3. So as you increase the units of labor, your productivity undergoes a change in the total productivity, average productivity, marginal productivity. This undergoes the change. This is a very, very interesting and important point that you need to remember, that you find the last slide I showed close. Marginal productivity intersects at the AP, at the maximum point of the AP curve, and this intersects with the level L2. Recall, whenever the MP is above AP, marginal productivity, to average productivity, average is rising, and it makes no difference whether marginal productivity is rising or falling. When MP curve is below AP, the average is also falling. Therefore, the intersection must occur at the maximum point of AP, and it becomes negative when the labor reaches at the L3. This corresponds, the TP curve also reaches maximum and starts falling. So 0 to L2 is defined as stage 1. MP of the marginal productivity of labor is positive and increasing here, but MPK is negative. In this range, there is not enough labor to efficient use of the capital stock, and you find beyond L3, MPL is negative. There is too much of labor combined with the capital stock, as it would make no sense to operate in either state of 1 or 3. Everybody would like to have in stage 2, and MP with the labor and capital is positive and declining. Production will occur only at this range. Everybody would like to have. So I'll stop here. This is what you have to understand about the